GeoTrig outline lesson 24. Today we're going to talk about two different things, two different topics. The first one is the sums of trig functions, and the other one is the operations with functions. Adding them, subtracting them, dividing them, multiplying them, and composition. So we'll start off with this one. This one is the sum of trig functions, and I've got three steps. Three very broad steps. Basically, today, you're going to be given an equation that says the sine of 30 plus the cosine of 30. That's what we're going to do. And so, my three steps are, when I talk about a trig function that has a value already, so an angle in it, the sine of 30, or the cosine of 30, or 45, or tangents, and so forth, they are numbers. There's a value associated with that. That's the same thing as me saying f of 2. So if f of x equals, so no different than what we did the other day, where I said x plus 3. So if I said f of x equals x plus 3, and I left it as f of 2, what would you do? You plug in 2 and then evaluate. It's got a number, right? This is associated with a number. Same thing with sine and cosine. If it's sine and cosine or tangent of an angle, we'll say, or a number, it's going to have a value. We're not going to make this scary stuff. There's no calculator needed. I would highly suggest that you put your calculator away and not use it for this stuff, because you'll find it's going to be quicker and easier. I don't want decimals. As in number 2, I want exact only, please. So, number 1, three things, I guess you should write on your paper every time you use it, or at least every time you turn the page. Draw the reference triangles. Some of us are still not there. Some of us still need to go back and say, what are the reference triangles? And those reference triangles, remember, as I said, I like to draw them the exact same way every time, is 30, 60, 90, and 45, 45, 90. Each one of these takes no more than 30 seconds apiece, if not even shorter than that. So you give yourself a minute to draw those out. And remember, they always have the same pattern. 1, 2, 3, and the larger number takes a second. That's the reference triangle for 30, 60, 90. I asked you to draw it the exact same way already, because it makes it easier. 45, 45, 90 is what? 1, 1, 2, and the 2 gets the square root. Okay? Now, we've used these two different ways. First way was actually evaluating trig functions, which we're going to do today. We're just going to chain them together, because we've done sine of 30, cosine of 30 individually. But today, we're going to do them individually, but on step number 3, we're going to add and subtract them left to right. Order of operations. Act like sine of 30 is its own parentheses, its own grouping symbol, which means I do that first, then I have to do the cosine ones, the tangent ones, and then I'm going to work left to right, adding and subtracting. Okay? Any questions to that? So we got two examples here where it's just going to say, hey, evaluate. I want exact only. No calculators needed. Actually, I'm going to say no calculators at all. We're on a new page. What should I draw? Triangles. I don't think that even took a minute to draw both of those. But we have them up there so we can use those in reference. And on the last page, I forgot to write down, I had it in the directions, sometimes it's very nice to have that phrase or that acronym of SOHCAHTOA sitting there so you exactly know which one is sine, cosine, and tangent on our reference triangles. So what I'm doing is I'm just evaluating each one individually. Cosine. I'm going to take cosine of 60 out. I'm going to place its value in there. Wait a minute. We need... Kelly. Ashley. Right. I want to multiply the bottom and top by the square root of 2 to get rid of that square root of 2 in that second grouping. Square root of 2, square root of 2. So I'm left with 1/2 plus 1 times square root of 2. Square root of 2. And square root of 2 times square root of 2 is square root of 4, which is 2. We now have a common denominator. It's happened to work out that way. It's not always going to happen that way, but I can now gather the stuff on top. Or can I? Can I officially put a 1 and a square root of 2 together? No. No. So they're going to be separated, but they are added together all over 2, which was my common denominator. Guys, that's the exact answer. I could take my calculator out. I could come up with this decimal. It's not going to be nice, but I can do it. I want exact answers, though, and that is it. I'll give you guys a couple seconds to do the second one. So, by now, I would think that we're pretty darn close to being done. Something plus something. Tangent of 30. Tangent is opposite over adjacent. Here's 30. Opposite over adjacent is 1 over square root of 3. We'll fix that in a second because we don't like the square root. And cosine of 45. Cosine is adjacent again over hypotenuse, so 1 over square root of 2. Oh, hey, do we remember that sine and cosine of 45 are the same because our sides, which are opposite and adjacent, are both 1s? Okay, now, if it happened to be that both of those end up being the same denominator, I can just add them together and fix it once, but one's the square root of 3 and one's the square root of 2. So in that case, I'm going to fix them first and then try to put them together. When I fix the first set, I have to multiply the top and bottom by square root of 3. Second group is square root of 2. So I end up with square root of 3 over 3 plus square root of 2 over 2. Oh. They're not together yet. I need to get a common denominator, right, of 6.
How can you multiply them? How can you multiply something to each side?
I need to, on the first one, I need to get a 6. The first one I need to multiply top and bottom by 2, and the second one by 3. So the 2 square root of 3 over 6 plus 3 square root of 2 over 6. Now I have a common denominator, so therefore, wait a minute, can I put those together on top?
Yeah. No.
No, because they are not the same. And I end up with 2 square root 3 plus 3 square root 2 all over 6. At least it's over a common denominator, even though it does not look nice. Now, these next two start to add a little bit more flair to the problem. Because if you look at the second one with the first problem here with a tangent, it's got a 2 in front. So that 2 is going to be multiplied to the value of tangent of 30. That's all it's going to do. That's the only thing that's going to change for us here. Hey, wait a minute. We're on a new page. And I need my reference triangles. So I'm going to draw them. Okay, so we have those. Now we have to do tangent of 45. So 45 tangent is opposite over adjacent, which ends up being 1 over 1. We like that. That's not bad. The 2 guys stays on the outside. And now I just have to do tangent of 30. And tangent again is opposite over adjacent. We go to 30. 1 over square root of 3. Guys, seems like every time I use this one with a square root, it ends up in the bottom. We always seem to want to change it, yes? In your head, can you change it already? Can you visualize what it's supposed to be? Yeah, it ends up being square root of 3 over 3. So can I do that right away? Save myself a step. And 1 divided by 1 is plus the 2. Remember, guys, this is a 2 times a fraction. It's really 2 over 1. So this would be 2 square root 3 over 3. That means I still need to get a common denominator. And that common denominator is, so it'll be 3 over 3. That's multiplied there. So I end up with 3 plus 2 square root of 3 all over 3. So everything, all it is substituting the appropriate value, exact values in for sine, cosines, and tangents. We dealt with some easy numbers here. Now they're starting to throw some not so nice stuff with square roots and everything. Guys, it's not going to change anything. The square root of 6 still stays outside. So square root of 6 times something. Maybe we can just start to evaluate this one as we go along. What's the sine of 30? This is one of those ones we should all remember. Just like the 45s. 1 over 2. Or half. Plus 1 over square root of 2. Tangent of 60. Opposite over adjacent again. Ends up being what? Tangent 60. Opposite square root of 3 over 1. And now it's just going to multiply. Well, if you remember, square root of 6 is really square root of 6 over 1. So I end up with square root of 6 over 2 plus what? Square root of 3 over square root of 2. I don't like the square root of 2's. Yes, I'm going to multiply top and bottom by square root of 2, square root of 2. I don't like that color on there. And so you end up with square root of 6 over 2 plus, square root of 3 times square root of 2 is square root of 6 over 2. Hey, that's cool. So that's obviously square root of 6 over 2 squared, right? 2 of them. I got a square root of 6 plus a square root of 6. How many is that? 2 square root 6 over 2. And, oh, the 2's cancel, and I'm left with square root 6. All of that work, yes, just to find out is the square root of 6. And again, I want square root of 6. I don't want that decimal. So, we are working with trig functions, guys. And we actually worked with the first 2 of this idea, combining functions. That basically says that I could take them individually, f of x and g of x, sine of 30, cosine of 30, evaluate them separately and add them together. That's fine. Most of us are going to be okay with the fact that I can add and subtract functions. And remember, functions here can be made up of x's. So x squared plus 3x plus 2 is a function. And I can add that to x plus 3. I just combine the x's and like terms and I'm good to go. Same thing with the difference. The difference between the sum and the difference one is that when I'm subtracting, grouping symbols or parentheses are extremely important. Because if there's a negative outside of parentheses, what are you supposed to do with it? Distribute the negative before you add them all up. So be very careful. Now, here's the cool thing. Now, a lot of times you see them stated as f of x plus g of x. But sometimes they want to save a little bit of ink and not have to write x twice. And so they write f plus g of x. Or f minus g of x. Or f times g of x. And this one gets a little bit smaller. We're dividing them, the quotient. F of x divided by g of x. They like to say f divided by g of x. Those, most of us are going to be okay with. Most of those we all have done already. We just didn't call them multiplying or subtracting, adding, and dividing fractions. We just did it. Okay? So the difference between what you've done in the past is that they're going to actually state two different functions and then ask you to do them individually. Versus just give you a problem saying, hey, take this and multiply it to that. Sometimes you distribute, sometimes you add, sometimes you subtract, sometimes you have to FOIL. Okay? Those are all things that you've done, and that is this stuff. Now the last one is called composition. Composition means I am going to place one function inside of the other. And this symbol here is an open circle. It looks like fog because of that, but it's an open circle. That means F composite G. That means G, if you notice here, is inside the function, where a variable used to be. So I take out the variable and actually place the whole entire function inside. We'll do examples of each one of these here next. So let's do that with these two functions. I want you guys to do all 5 combinations from above, or actually in the last slide. So the first one we're going to start off with is addition. F of x plus g of x. I'm going to do exactly the way it says. The thing is, that's going to be different here is I'm going to use parentheses around things. I am going to say, hey, what's f of x? By substitution, f of x was x plus 3. Then I'm going to add that to g of x. I'm taking g of x out, placing in what? X squared plus 6. I am taking out f of x and g of x and replacing it with its perspective values or equations. Because that's what they're equal to. F of x is x plus 3. G of x is x squared plus 6. So I place them here and here. Now the thing is, I'm adding. Do I need those parentheses on there? Is there anything outside them? No. So that's going to equal x plus 3 plus x squared plus 6. Now it just becomes, I just got rid of the parentheses, that's all I did here. And now I just need to put it in standard form. Gather like terms.
X squared plus 9.
Plus x plus 9. It's not the quadratic formula, it is a quadratic formula. Okay? So this should not be a problem. We've gathered like terms before. Now, the next one is f of x minus g of x. Now this one does have a slight twist because yes, I agree, it's still x plus 3 for f of x. It's still x squared plus 6 for g of x, yeah? But what's between them?
Negative sign.
A negative sign. Now, do you need parentheses?
Yeah.
Yes. Does the first set need them though? No. That is, or stays, x plus 3. But here, with this negative sign, I need to distribute. So it actually becomes a negative x squared. And minus 6. Seeing the slight difference here. That negative changes things. It's like a number outside of a set of parentheses. It needs to be distributed. And so now, when you put it in standard form, so negative x squared. Still plus x, okay. Minus 3. So they are different. And they should be. If I add two things together, it should be different than when I subtract them. F of x times g of x is x plus 3 because that's f of x. G of x is x squared plus 6. What do I have to do now? You have to FOIL. Okay? We've done that before. So, first, outside, inside, last. I'm going to leave that for you guys to do. Simplify, put it in standard form. The second to last one is f of x over g of x. So you're dividing the functions. And if you're going to divide the functions, we still have to write it as x plus 3 over x squared plus 6. Now, it's kind of a toss-up here. Sometimes you can do more. Sometimes you can't. Then what I mean by do more is, can you simplify it? X plus 3, that's in simplest form already. Is x squared plus 6. Can I factor that or break it down more? No. So therefore, I cannot cancel anything. There's my answer. Okay? So you just leave it like so. The last one. F of g of x. I'll change the color here because f is your outside function. Guys? So I am going to write down f of x. And f of x was something plus 3, yes? Guys? It's something plus 3. That was where x was. The composition, guys, is where I take out that variable and I place in there the other function completely. And the other function, x squared plus 6. And then you use your order of operations. Do I really need those parentheses? So it just becomes x squared plus 9. Okay? You're taking out whatever x is. And if there's multiple x's, I take all of them out and plug that function in. Your homework is lesson 24, page 176, 13 through 15. Have a great day.